Hello everyone, and today I'm going to be showing you a video on the functional programming language Haskell. Now I've done a few functions which are mathematical in nature, and there are a few that are kind of logic based for upper and lower case text and strings and all this. So today I'm just going to run through a few of these functions. Now don't worry about the green, this is just the comments that describes them, but I'll give an overview after I show them all working. So I have an import here, but don't worry about that, that's for later on, about the strings I was telling you about. First function is add and double. So if you show them in here, it takes in a number to the function in the class of num A. So it takes in a number and another number, and it gives you out a number. And basically the AB is you're doing A plus B and then you're multiplying that answer by 2. So you're adding and doubling, just like the description. So you put in 2 and 5. 2 plus 5 is 7. By 2 is 12. That's how this one works. Now our next function is an infix, which by using brackets means that you can put, same as above, but you can use 2, say, plus multiply 10. And that will give you the same answer, because 2 plus 10 is 12, by 2 is 24. Same idea, and then this is making the infix as a name as well, so you could even do this. Back and double prime, backslash, and 10, you will get the same answer. That's infix notation. I decided to do both because it seems good to have a symbol. And only you need to use backticks when you're using text. Alright, the next one, obviously now I've just realised I corrected a little logical error in there. That there seems to be that if it's not a number, which is a function in Haskell, it will return false, and then if it is not a number for upper, because the discriminant may not always just be a negative square root in order to get not a number, because there is somehow something that's going on there that's making the equation not a number. So carrying on, we have the solve quadratic equation, because you see that the discriminant is the square root, is if it's negative or it's not a number or it's upper, then we send that it's a negative result. Otherwise we return the tuple of the maximum and minimum, which are defined here by b, negative b plus the discriminant, or negative b minus the discriminant, over the 2 by a. So when we put that in here, we can put in, say, 5, 10, 5. That's the basic one for negative 1.0. If you put in the 12, you get that. If you put in a ridiculous number, it will return a negative result. Okay. Now this one is, as you say, it takes in 3 double values and it returns 2 doubles of A, B and C, which are all in the equations. Now first then, because you see you can go online and you can find out these quadratic equations are correct. When you put them in online, they will match the same results. Right. So this one is the first n integers. It means it will give us the first integers that we enter. So if we enter 5, so if you see this, first n integers equals, say, 5. You get 1, 2, 3, 4, 5. You can n the number itself into its function. If it's less than 0, we put in less than 0 as the exception. Here we have the default case of whenever we pass in, when it gets down to 0. So here it's taken a list of n's up to an infinite list. So if you do that, it returns an empty list, which is why when it gets 1, 2, 3, 4, 5, next one is 0, so it's blank, and it doesn't return anything. So that's the base case. If you put in first n 0, you get an empty list. Put in minus 5, you will get a problem. But you see, that's because to do a minus 5, you have to put it in cases like that. See, because it thinks you're passing in different parameters there. So when you bracket it, that means minus 5. Right, so that one's error checked. For first n integers, it's just basically the same thing, but done with regards and if you put in again, we'll try -4 as its exception, and if you put in a normal number you should get the same result. But we're not using an infinite list with that, we're using a recursive function. You see we have an integer and it returns a list of integers. So let's take one integer from in an infinite list. The integer takes in an integer, a list of integers, which is the infinite list, returns integers. So when we take the integer of x in excess, we're taking the first integer along with the first of the infinite list. If it's less than 0, you get that negative value. If you put in 0, you get an empty list, as you can see here. And otherwise it'll take the x and concatenate it onto a call to itself, the number down 1 to excess. So when it hits the 0, this guard will mean that it'll put a blank list, so it'll go 1, 2, 3, 4 times, put in an empty value, and it will just returns the 4. It's the same one. So then you have double factorial. What you do is, if the n is 0, you get back an empty list, so it's the same as the other one. We have a recursive function that calls itself and it calls the other function. I'll explain that later. Put in 12. You get all the factorials going down to 0 there. So 0 factorial is 1. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 values coming back. You wanted the first 12 factorials. 0 factorial is in fact a factorial, so you only want up to 11 factorial here. So that gives you back 12 values. Now what it does is, you take the factorial n minus 1, which is the value itself, where the factorial is defined here as an integer, returns back an integer. Now if you notice up here we're taking in an integer, and obviously we're given back a list of integers. So if the n is 0, it just adds empty to it. Otherwise, which is the main function, it'll take whatever the answer this little sum here is, and then add the next number down 1 onto it. So it calls itself, that calls this, that goes down 1 more, and it goes round and round till you hit 0 here. Comes back with a 1, so anything multiplied by 1 is obviously itself. And at least if you're at 0 or 1, you'll always get a 1. So basically what you have is, when the n is less than 0, it will error straight away. So let's try that. Try and put a negative value in. Negative number is entered. Otherwise it does the n multiplied by itself again, down 1. So what happens is on the first one it will do, say, 10 by 9, and then 10 by 8, no, and then it'll call itself. So the 9 will become 9 by 8, and the 8 by 7, 7 by 6. And then when it finally gets out of this, it goes in down 1 again. So this number will be then 9 by 8, 8 by 7, 7 by 6, all the way down, and you get your factorials by the end. Now if we run this one, we have factorials. And you have the first, say, 5 factorials you want. And that's 0, 1, 2, 3, and 4. Because they're the first technical, they're the first 5. And we're using the zip with function. Now what you're doing is, if the n is less than 0, you give back a list. Even at 0 itself, I think this should work. That's right. Instead of giving back an error, we just give them empty. Otherwise, what we do is we take 1, which is the first factorial, zip with, multiply on the whole list, and a call to itself down 1. So it takes, say, 1, and then zips it with the number below it, and then the one below that, and it's recursion, so it will continue to call itself, and multiply the 1 by its number below it, and then around and around. So if we take our last example at 12, we're getting the first 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Basically the same as our last question above there. Okay, our next one is prime, which gives you prime numbers which divide into either its number 1, divides into 1, or itself, and that's the only numbers it is allowed to divide into. So it returns true or false depending on whether it is prime or not. As you can see, you have fully working all the way up to whatever number you want to decide to check if it is prime or not. And the way this works is it divides n into itself, and it must equal 0, and then it must also check true or false in another call to n and n minus 1, which is how it's going to count down. If 2 divides into it, 0, otherwise a into that is not equal to 0, and is prime on itself again, which just checks basically that these must be true to return true for the boolean that we passed in the integer for. And then if you enter in a negative number or even 0, you want to say it's a negative number because you have to divide by 0, so you want to protect yourself against that, as you can see. So basically it's the number 5 divided into 5 must equal 0, the modulus, which means it must divide evenly, and then it calls n with n minus 1, and it checks every single number down to when n hits 0 to check that it doesn't match anything, and it must not equal to the evenly divide, otherwise it comes back false here, so that and that would be false, so it's recursive. Now this one does the same as its one above, and it checks out that every single one does not divide into another number evenly, otherwise it's not prime, so that's how you get true or false. The next one is called primes, which gives you back the first 6 prime numbers, 1, 2, 3, 4, 5, 6. So from our first primes. Now this is defined by integer, and it gives back a list of integers, which calls this prime count function, which I got for aid. It takes in 2 integers, and it returns the list. So this is essentially returning you the list. So you're passing in 2, because that's your first prime number. So if you have a negative number entered, it does the same. So if we enter in minus 6, negative number entered, 0 just gives you back a neutral list. That's needed in our recursive function. Otherwise, if is prime n, which uses actually my prior function as well in this one, if the prime comes back true, then you can then you can do the n, that number included, combined with prime count a down 1, and number goes up 1. So this one then checks the next number in the list. We know that 2 is the first prime, it will come back true, but we needed it for the recursive function. So then it's going down 1 and up 1, which you can see it's passing in the next number to check. So we're going down all the way from your count. Say you enter 6, that will now be 5, 4, until the number equals 0, and then returns back with just the blank, so you get the exact numbers you want. Otherwise it will just do not n concatenated on, it'll do the same kind of count, but it'll go to the next number up to check. And it won't go down 1 number here because you haven't found a match. You want your 6 numbers back, you can't take 1 off if you haven't found a number to show back, otherwise you'll only get 2 or 3 numbers for the 6 they wanted. Now our next one is some integer list, and this one is the x in excess because it takes in a list of integers and you want to add them together. So you have some integer list. So you have 1, 2, 2, 2, 4, 3. And you get 10. 3, 2 is 5, 7, 9, 10. This works fine with minus numbers as well. Because you have 1 plus 2 is 3, 4, 5, 6, 7, 6, 5, 4. Because obviously when you add up and minus, it just does like basic multiplication and addition. If you add a minus number, you go minus. So this is perfectly fine for error checking. You get a 0 if you're passing an empty list. So that's fine because it would be 0. Now what it is doing in this function is it is taking the number and it is adding the rest of the list on its call. So it's calling itself recursively. So it's the x plus, and it works out all the way across to how many numbers you have, and then it finally can come all the way back up. Alright, so basically then the whole list will come back as a whole string list of all these plus, 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 ultimately a number of each one in the list, and then it adds them all up and returns you back the number, which is how you get 4 here and 10 here, and obviously you get 0 from the base case. Okay, some integer list in terms of fold_L is you pass in the list, you get the same out, but we're using a function called fold_L, which folds in from the left side. We have an accumulated value which we will be returning. Obviously we have 0. We're going to do 0 plus the first element in the list, and then the next element is added to that. So this value accumulates the whole way up, and then it will return after the end of the list the same value as this one. Well, it does the same basic thing. So if we entered in the same number of the list, 1, 2, 2, 2, 3, we find we have the same answer. And for a base case, it's still just 0 anyway. So that's already handled in the fold_L function. Next up we have multiply integer list fold_R, which just folds the list in from the right hand side. And we're using multiply instead of positive here. We have a base case for when you enter in 0 that we're going to get 0, otherwise we would just return 1, which makes no sense for an empty list to be 1, so we have to catch the 0 here. And then it's basically taking it from the right, so obviously we need 1 by the number, by the next number, by the next number, because if that was 0, the list would be returned nothing but zeros, regardless of what we entered in. So if we put in fold right blank, we get 0. If we put in 1, 2, 3, 4, 5, we end up with 120. And by another 5, 600. So this is working correctly as well, and has a base case that we had to define in this case because it was multiplication. In addition, it didn't matter, 0 plus 0 is 0. Now we have the new function, one that I needed the import for that I mentioned earlier. This is called guess. So if you enter in, I love functional programming in any kind of case, and a number lower than 4, it will return guess again. Because you have to enter it exactly as it wants for itself, which means that if it equals that, so you have a typo in there, that you get it as 1 regardless of the lowercase here, and that is because I'm using fold case S on the string that you passed in. So what it does is it folds it, as in it takes it all to lowercase. So then I'm comparing it to a lowercase version of its own, and we're adding, and if the number is lower than 5, you have 1, otherwise you guess again, which is because I had the string wrong, that's how we got guess again. So even if you enter that in and you enter in say 8, you lose. That's what this one does. So it's taken in the string and the integer and returned back the string that you have lost, you have 1, or guess again. So if these two cases are right, its conclusion that you have lost is the only other option. Because as long as the n is less than 5, you will always get these two answers. As long as you put this in right, or you've got it or it doesn't, you get guess again. So that was used, if we come back up to the top, import data.caseInsensitive, and we're importing the fold case function. So just to kind of show you that, fold case is from this internal fold case where I imported it. It takes in a string and then the fold case type S. It takes in a string and returns back a string. So that's how we get the answers there. Now we have, after this one, we're finished. The dot product is that we're supposed to add the A and B tuples together. And what we need to do with this list of tuples is return back a number which is the number plus the next number. No, it's the A by the B, and we're going to take in, add the next one. So we did this with a list comprehension. So if we put in dot product, take in a list of these tuples. If you take in 1, 2, 3, 4, no, 3, 5, 6, 9, you get 71. Let's take a simpler one there, so we can kind of see what's going on. 1 plus 2 is 2, no, 1 by 2 is 2, plus 1 by 2, which is 2, is 4, and then plus 12 to 4 is 16. So what's happening is taking in, has to be a number A type class, and returns back a number. What it does is it takes a list of x's, which is our list, and what we're doing is we're going to sum the whole thing after it's done. What we're doing is we're taking each tuple as AB from the list, and we're doing the A multiplied by the B. And then the sum of that means that all the answers we have got in this list will be summed. And the sum function takes in the list and will sum all the numbers together. So whatever answer we have, it will add to each one of the lists at the end. So this is equated first, and then the sum is equated, and then that's our answer. Let's return back. Our next function is called isEven. And if you put in an odd number, you get false. Put in an even number, you get true, and so on. This one wasn't too bad to implement. It's a very simple function. You're taking an integer and you're returning a bool, so it's true or false. So isEven on the n that you've entered in. If the n divided into 2 is actually equal to 0, then it divides evenly, which means it's true, because that's our definition of even. Otherwise, obviously, it's false. It's not divisible into that, which means it's an odd number. Now, our next function is called Unix name. Now, what this function does is it takes in a string and returns a string, and you enter in something that has A, E, I, O, U vowels, either upper or lowercase, and it will filter them out and leave them blank, replaces them with nothing, so you don't get any vowel. So if we take a look, we can put in anything in any uppercase, and it will filter out all the A, E, I, O, U. It still leaves the spaces because they're not A, E, I, O, U. So if you put in an uppercase E, you still get the fact that it doesn't show up. Now if you put in an empty string, we have to enter something to check. Now that's error validation. So we have, if the whole list is empty, it's not a guard. You can't do it on an individual character because we have took a character out of the string. We can't check for an empty character. So if the whole list is empty, we passed in, then you have to enter the error, please actually enter something to check. Otherwise it will run. What it does is, if the rest of the list is empty, we're obviously on our last character, so the elements has got one of these. If it is not, then you can include the character. Otherwise, obviously, it is a vowel and we leave it empty. Which is how we get this, because the string is a list of characters. Basically, that's how we're filtering through the x's. So if x is, otherwise what we're doing is, because it's not the last element yet, if x is not an element, then we add the x concatenated with the call to itself recursively on the rest of the list, which will then do this again until it hits this, and then it'll check the last character and come out. Otherwise, we don't want to add that x to the list, so we just call it again. And it goes round and round, so we get the correct values. Alright, we have intersection, which I called an aid function for our next one, and it is intersection. I'll show you an example of how this works first. We'll say 1, 2, 3, 4, 5, 6, and then we have 1, 3, 5, 7, 9. Now what this does is, it gets the numbers that are common to both in the order they are in. So only the matching numbers will come back, as you see 135. And entering in empty lists turns an empty list, which is kind of simple because obviously we haven't entered anything, and that's the cases we have here. So it's equal, it must be of the equal type, it must be equal to a list of A's, and returns back a list of A's. So that means that they have to be comparable. You have to be able to compare them for the boolean. So what we do is take the X in the XS and we keep the second list as it is, and we call list check, which is this other function, and you add it to a call to itself with the rest of the list and then the normal list again, because we're comparing against the second list all the time. So we drop the X and go round again. So what this one is doing is it's taking in a single number, which is why we have the X, and we have the rest of the list. And if the list is empty, you return back empty, which is how it comes out and goes round again. Otherwise we have a guard where we're taking the X, we take the first element out, and if the X is equal to Y, we've matched it, so we can put the X into the value. We could have done the Y, but it doesn't matter, so we just keep the X. Right, okay. So now we have gone through this, and what it does is the list is added to the number, and we basically come back. Plus is like adding to the list, so each one of these will return the whole list. So if there's 4 numbers matched, we'll bring back them numbers, and then we can add it to the rest of another list, which will give you the whole list back. Eventually you'll do this by the list, the 2 by the list, and then the 3 by the list. When you hit the 6, it comes back with blank, so that's how you get the list here, 135. Sensor is our last function, and it is a string, so we can do the same as the last one. It's exactly the same, except that we have it where it's replaced with X's instead of blank spaces. And we have the same error function for this one. Now what you're doing is, error in there, guard, a pattern matching, and then we have the 3 guards. So we have the rest of the list is equal to empty, and we know on our last element as before. Otherwise we put in the actual number if it's not an element of A, I, or U, we know we need that. But this case is different from the last one, in that we're actually putting in the character X instead of leaving it blank. So that's how we made the difference in this one. And then we do the same, if not the element, then we put the X tied to the rest of the list. Otherwise we can just put in the character X with the rest of the list, which is different from this one because we just wanted it left blank. Here we're going to put a character on. And that's how the sensor works for all these functions. Well, I hope this thing was interesting and can show you that functional programming is an interesting alternative to normal Java programming or any of the normal C++ languages, and that it does have its own uses. And hopefully this has been of some use to some of you out there, and you might give it a try. Alright, thanks for watching.